Hey everyone, Mr. Fransky here. We're going to be going over section P2 in pre-calculus today. This is just an intro to the Cartesian coordinate system. P2 goes through all kinds of stuff in the Cartesian plane. This video is just going to focus on graphing points and finding the distance between 2 points. Vocabulary we're going to go through today, the Cartesian coordinate plane, and we're going to talk about where that word Cartesian comes from, what coordinates are, the quadrants that you're looking at in the Cartesian plane, and then we're also going to be looking at the distance formula. So, to start off, let's just do a little bit of bell work here. Why don't you chat with a neighbor about what you know about these things that we just mentioned: coordinates, quadrants, distance formula, maybe the midpoint, and maybe the equation for a circle. So you can pause the video if you want to chat with your neighbor just for a second. All right, welcome back. So we're going to cover all these things in section P2. In this video, we're kind of just going to cover the first three. So let's start with a quick refresher of what some of these things are. So this thing right here, you guys may have called lots of different things: the coordinate axes, the coordinate plane. This is officially called the Cartesian coordinate system. That word Cartesian, I wonder if you've ever seen that before. Cartesian is named after a fancy guy named René Descartes. René Descartes. Descartes was in charge of developing a lot of geometry, and you can see that Cartesian is kind of hiding in there. He dealt a lot with what we're going to be talking about today. So just a few things to remember. The x-axis, remember, is that horizontal axis. The y-axis is your vertical axis. The origin is right here. It's 0, 0. That's where you start everything. That's why it's called the origin. It's where everything begins. Really, the Cartesian coordinate axis is just two number lines, right? The x-axis is one real number line, and the y-axis is another real number line. And so a coordinate pair, or an ordered pair or coordinate pair, x comma y, tells you how far to go on the x-axis and then how far to go on the y-axis. For example, the point right here would be -3, 2, because you go to -3 on the x and +2 on the y. This is all stuff you've seen before. That point, remember which quadrant it's in? I think this is quadrant 2. It starts in the first quadrant and it goes counterclockwise. So 1, 2, 3 is down here, and then 4 is right here. The best reason I can think of for why they numbered the quadrants in this manner is because in trigonometry, which we're going to learn about later this year, that's the order that radians go in the unit circles. So we'll learn about that later on sometime in semester 2. So just a quick refresher of some important things that are going on with your coordinate axes. So I find that every time I ask someone about the distance formula, they remember, yeah, there's something about a subtraction, there's a square root. I don't know exactly what it is, but I know a few things about it. And for me, I actually don't have the distance formula memorized. Sometimes, you know, if I've been using it a lot, I'll start to commit it to memory, but it always seems to fade away, and I always have to remember how to derive it. So I'm going to show you right now a really quick way to derive the distance formula, because it's actually really easy if you just draw a picture. I know for some people, like, I'm a visual learner, so drawing a picture always helps me. But what I'm going to do here is I'm going to pick 2 points, and we're going to find the distance between them. Let's call this first point right here, let's call that x1, y1. So those are 2 coordinates. Maybe it's like 3, 2 or something, I don't know, but just x1 and y1. And this point over here we're going to call x2 and y2. So we want to know the distance between them. Let's use a different color for that. Let's make it red. So we know the distance between them right here. That's what we want to know. I'm going to call it D. Okay, there's our D with my horrible handwriting. All right, well, if we want to know that D, there's a trick to this. What we can do is we can just make a triangle. You see me dyeing a green on the bottom here. So we can find that distance without any trouble. And I think we can find the vertical distance too. There's purple maybe here. Okay. So that purple distance, since I just drew it, it's just the difference from the y-coordinate of this point and the y-coordinate of this point. Check it out. Like if this was, I don't know, 5, 4 or something, the y-coordinate up here would be 4, and this guy down here would have a y-coordinate of maybe 2. So that distance we can just get by subtracting the y-coordinates. This is just y2 minus y1. The green distance over here, that green distance is just the differences of the x-coordinates, right? If we think about the x-coordinates here on the x-axis, we can just subtract them to find that distance. That's x2 minus x1. And what have we created here? Well, we've made a right triangle. Look at that. And if there's one thing that anyone ever remembers from math, and I promise, ask your parents this, be like, what's the one thing you remember from math? They'll be like, I remember the Pythagorean theorem, right? So the Pythagorean theorem, if you have a triangle, and it's a right triangle, legs of A and B, this is C, A squared plus B squared equals C squared. Well, we're going to do the same thing with the distance formula. It's just that we have more complicated legs of the triangle. So what we're going to do here is we know that D squared, keep with our color scheme, D squared is equal to the square root, so D squared is our C, so that's our C squared, so A squared plus B squared. So we're going to do, in purple, no, let's do the green first. So we have x2 minus x1 quantity squared plus the vertical leg squared. So that's our y2 minus y1 squared. So this is just the Pythagorean theorem written out exactly for this right triangle. And then how do we finish it off? We just take the square root of both sides. So the distance formula, the distance between any 2 points, is just the square root difference of the x's squared plus the difference of the y's squared. There's your distance formula. That's all there is to it. Now, this is, I don't think, is a formula worth memorizing. I just remember it's the difference of the x's squared plus the difference of the y's squared, then you take the square root. So let me show you how I do that. So let's find a few. Let's do the first one together. I want to find the distance from -2,4 to 1, 0. Now, the way that you might have learned this the first time in maybe Geometry or Algebra 1, you're probably taught to label these points. x1, y1, x2, y2. I never do that. I never do that. All I do is I remember, okay, I need the difference of the x's. Well, how far is it between -2 and 1? I think that's 3 units, right? So I'm going to do the square root of 3 squared, because that's the difference of the x's. Remember, all I'm doing here is the difference of the x's squared. And does it matter if it's positive or negative? I don't think it does, because if I subtracted them the other way and got a -3 and squared it, I'd get 9. Same thing. Difference of the y's is 4, so plus 4 squared. 3 squared is 16. Sorry, 3 squared is 9. 4 squared is 16. Square root, that's the square root of 25, which is 5. That's all there is to it. Why don't you try the next two on your own? Go ahead and pause the video for a second. All right, let's see how you did. So this one, I'm going to do the square root. Difference of the x's is 5 squared. Difference of the y's is 3 squared. So that's the square root of 25 plus 9. That's the square root of 34. That's 2 times 17, so I can't simplify that at all. There are no perfect squares in there. I'm done. Next up, we got -2, -6 to -4, -8. Now, this is especially when all of that subtracting, I just think it's so confusing. You can do it this way. If you know this, if you have this memorized and it works for you, awesome. But what I'm going to do, square root, difference between -2 and -4, that's 2. Difference from -6 to -8, also 2. Square root of 4 plus 4, that's the square root of 8. I can pull out a perfect square from that. That's the square root of 4 times 2, which is 2 times the square root of 2. Cool. That's all there is to distance formula. I kid you not. So that's it for this video. Next video, we're going to talk about the midpoint formula. Hope you learned something new.